Hello, Professor. My name is Kumudini, and today I would like to demonstrate my Lab 6 for DPS912. So, this assignment is about implementing inter-process communication between two separate programs, a server and a client, using AF Unix domain sockets on a single Linux image machine. The server acts as a master that sends a fixed sequence of text commands such as PID, sleep, quit over the socket, while the client acts as a slave that receives each command, performs the requested action, reporting its PID, sleeping for 5 seconds, or terminating, and sends a response back before the server proceeds to the next command. This synchronous request-response pattern means the server always waits for the client's reply before issuing its next instruction, which keeps the two processes tightly coordinated. The lab reinforces core systems programming concepts, socket creation, binding, connecting, blocking reads and writes, process identification via get PID, and proper resource cleanup, closing the sockets and unlinking the socket file. So let's go ahead and look at the terminal. So here we have three files: server.c, client.c, and a make file. So let's look at what we have in server.c. So in our server.c file, we have a socket, which is AF Unix sock stream 0, as you can see, which creates a Unix domain stream socket. And we have an unlink socket path in case a previous run crashed and left the file behind. Then the bind fails if the path already exists. The bind command function attaches the socket to that path. Listen starts listening for one connection. The accept function blocks until the client connects, returns a new FD for that connection. Then it's just 3 write read round trips. So write PID, read response, and it prints it. And then write sleep. Where is it? Yeah, here. Write sleep over here. Write sleep will read the done, ignored content just used as a sync signal, and then it write quit. Finally, it will close the it will close both FTs and link and unlink the socket file so it does not linger on disk. So that is close and that is to quit. Now let's look at the client.c file we got. So in the client.c file that we have a socket function, then connect to the same path, and that sits in a while loop. Blocking on read for the next command. strcmp dispatch that will say PID, and then it builds this client has PID %d with get PID and write it black. The sleep that you can see here will sleep for 5 seconds with sleep 5 function, and then it writes done, which quits, breaks out of the loop. So after the loop, it closes the socket and returns 0. Now, why is it synchronous? The server never calls write for the next command until its matching read for the previous one has returned. That's the whole synchronization mechanism. No threads, no select, no non-blocking flags needed, right? So now let's run this program to see how it works. Let's firstly let's run the make command to run both the files. And now let's execute the server file. So now we can see that it's waiting for the client. So we open another terminal and now we execute the client program. So a request for the client's PID has been received. This client is going to sleep for 5 seconds. So if you noticed it slept for 5 seconds. Then the client is quitting on the client side. On the server side, however, we can see that it was waiting for the client. When we ran the client command on the other terminal, the client connected to the server and the server is accepted. So it says server accept. The server requests the client PID. So the server has requested the client. So the client will send us the PID, which is 5319. So this client has PID 5319. The server requests the client to sleep. That's when this client is going to sleep for 5 seconds. And then the server requests the client to quit. That's when the client also quits. Now, let's clean the make again and try to see how error handling works for this assignment. So let me clean it. So it's cleaned. Now let's make it again. This time let's try to run client first before we have we run the server. So now we are executing the client program first, which should give us an error, right? So if we run the client before server, it should fail gracefully with a P error message that says connection refused or something similar to that. So here it says client connect, no such file or directory. So it does not crash, but it gives us a proper error message. So that's error handling. And in fact, we can also check if we have any socket file is removed or not after we run this. So let's clean it again and then run it. Now let's execute server first and then let's execute client here. So we're just going to repeat what we've done with a different PID now, and it's quit, right? So it's done, right? Now let's check if we have anything inside our lab 6. Let's check if there is anything. So it says cannot access no such file or directory, which means it should be gone, like it's gone. If it's still there, then your unlink call is not running, but since in this program it's running properly, we don't have any problem. So you're exiting before reaching cleanup on some path, but here that's not the case. So the most challenging part for me was to find the right kind of function writing for the client file where, I need to look for string compare dispatch, and then, then you build it and then you get the get PID. But overall, I think I've implemented everything that the lab wanted. So I would give myself a 9 out of 10. And I hope you enjoyed my presentation. Thank you so much for watching.